Okay, students, let's have a discussion for the topic electrostatics. That is the first topic of plus 2 physics. Electrostatics. Electro means charge, static means at rest, means the study of charges at rest. That is called the electrostatics. So for this, we have to define the charge. Now what is this charge? Charge is an additional property of matter which is responsible for the electric forces. Electric forces may be repulsive or may be attractive depending upon the nature of this charge. And the charge, every charge, that is the elementary value 1.6 minus 19 coulomb. This is elementary charge. Here E means elementary charge. If it is positive, we consider it plus E, and if negative, we consider it minus E. Means charges of two types, positive and the negative. Now these charges in electrostatic, where the charges are static, how we get the bodies charged? We have the two methods, electrostatic conduction and electrostatic induction. Means conduction when there are actual contact of two bodies. For example, when we rub glass rod with a silk cloth, they are getting charged. In this rubbing, there is a transfer of electrons. Actual transfer of electrons. That is the cause of this conduction. Means bodies get charged, getting the static charge, acquiring the charge by rubbing with each other. Rather, there have some pairs. Not each bodies get charged by rubbing with each other. There are some pairs that is responsible for this conduction. That is the transfer of electrons. What is the cause of this electrostatic conduction? Transfer of electrons. And in induction, there is no contact between the two bodies. The placing of a charged body near the uncharged body will give the induction, will induce the charges. That is called the electrostatic induction. Means here the redistribution of electrons. This is 1 mark question. What is the cause of electrostatic conduction? Transfer of electrons. And what is the cause of electrostatic induction? Redistribution of electrons. And this charge, they have the many properties. Like charges repel, unlike charges attract each other. This is the elementary charge. They are additive in nature. Means always add, additive in nature. They are conserved, means charge neither created nor destroyed, it is conserved. Like in glass rod and silk cloth. Before rubbing, no charge, net charge is 0. After rubbing, again the net charge is 0. Glass rod acquire the positive charge, then the silk rod acquire the equal amount of negative charge, and the total charge again become 0. And invariant nature. Invariant means the motion of body doesn't affect the charge. But in case of mass, the motion of body affects the mass. That is according to the Einstein, 1 minus v square upon c square. This is the rest mass. But the charge is not affected by the motion of the body. So charge is invariant. And the quantization means charge is quantum in form, packet energy ਜਿਹਨੂੰ ਕਹਿੰਦੇ ਨੇ ਆਪਾਂ. So charge is quantized. Charge is an integral multiple of this E plus minus. Means integral. This is a full number, not in fraction. This is called integral multiple. So charge is conserved. And the cause of this quantization is a transfer of this electrons. Means the bodies when get charged, there is a transfer of electrons. And electrons are not transferred in fractions. They are always transferred in a full form. That is called the quantization of charge. And this quantization of charge is neglected in macroscopic level. मतलब ਜਦੋਂ ਅਸੀਂ डेली लाइफ चार्ज की गल करांगे, प्रैक्टिकल लैवल च गल करांगे, उदों असीं इस डिस्क्रीट नेचर की गल नहीं करते, उदों असीं सिर्फ कंटीन्यूस डिस्ट्रीब्यूशन की गल करते हैं। और इन्हां चार्जिस दे विच जिहड़ियां फोर्सेस ने दैट इज एक्सप्लेन्ड बाय द कूलम्स लॉ। That is the basic law of electrostatics, Coulomb's law. And what is this Coulomb's law? Coulomb's law. Two charges, force directly proportional, inversely proportional to distance, Q1 Q2 r square, constant Q1 Q2 r square. This constant is proportionality constant and its value is depend upon nature of the medium and the system of units used to measure that quantities, that is the value of this. So in SI and vacuum or air, the value of K is 1 over 4 pi epsilon naught 9 into 10 raised to power 9 Newton meter square per coulomb square, where this epsilon naught is called absolute permittivity of free space. Absolute permittivity of free space. How the medium affect the charge force? That is absolute permittivity. What is this? How we get this? From where it get? This is not the part of your syllabus. You just only remember this absolute permittivity 5 4 minus 11 per Newton per meter coulomb square, and we got this value, that is K, constant of proportionality. Now how we write the force in vacuum? 9 into 10 raised to power 9 Q1 Q2 upon r square, or we can say 1 over 4 pi epsilon naught Q1 Q2 upon r square. But if the medium is changed, and how we write the force? 1 by 4 pi epsilon Q1 Q2 upon r square. Here epsilon is called the absolute permittivity of medium, because with the change of medium this force is affected. And how we get this? Vacuum medium. Then we have epsilon naught, epsilon r, or capital K. This is the small k, proportionality constant, and this is the dielectric constant or relative permittivity. Then how we write this epsilon? Epsilon naught epsilon r or epsilon naught k. Means this force F medium is written as 1 by 4 pi epsilon naught epsilon r, or we can say k Q1 Q2 upon r square, or F medium become F vacuum upon K. Means with the change of medium the force is also affected. And how this force is used to define the unit of force? By using this Coulomb's law, if we say the force is Newton 9 Q square 1 meter distance plus minus 1 coulomb. So the unit of charge is 1 coulomb. Means in SI system, charge is said to be 1 coulomb if it placed in 1 meter in vacuum and repel the same charge with the force of 9 into 10 raised to power 9 Newton. मतलब charge 1 coulomb उदों हुंदा ਜਦੋਂ ਵੈਕਿਊਮ ਦੇ ਵਿੱਚ 1 ਮੀਟਰ ਡਿਸਟੈਂਸ ਤੇ ਪਿਆ ਤੇ ਸੇਮ ਚਾਰਜ ਨੂੰ 9 into 10 raised to power 9 ਨਿਊਟਨ ਦੇ ਨਾਲ ਕੀ ਕਰਦਾ? ਰਿਪੈਲ ਕਰਦਾ. And how we write this Coulomb force in terms of position vector? Position vector. How we write the vector? Before this position vector, we have to express the Coulomb's law in vector form. Before this, we simply define it with simple vector form. Vector form. Two charges Q1, Q2, distance r. Now they repel with each other, same charges, and this force is 2 1, 2 1, and this force is 1 2. Now its unit vector is 1 2 cap, 2 1 cap. These two forces magnitude is same, 4 pi epsilon naught q upon r square. But when we write it in vector form, epsilon naught r square. Now this is 1 2 means this force, and for this what is the direction of unit vector? 2 1 cap, and then 2 1 force 4 pi epsilon naught q2 r square 1 2 cap, as 2 1 cap is minus of 1 2. They are opposite directions. These are the unit vectors whose magnitude is 1. If we put these values here, in this place, I place this negative value. So what we got? 4 pi epsilon naught r square 1 2 cap means F21 negative. Means these two forces are exist in pairs, and they are the central forces also, because they act along the line joining the two charges, and pair means this vector form is more informative than the scalar form of this force. मतलब vector form ਕਿਹੜੀ ਚੀਜ਼ ਨੂੰ ਜਸਟੀਫਾਈ ਕਰਦੀ ਆ? ਸੈਂਟਰਲ ਫੋਰਸ ਨੂੰ ਔਰ ਪੇਅਰ ਇਨ ਫੋਰਸ ਨੂੰ ਜਸਟੀਫਾਈ ਕਰਦੀ ਆ. ਨਾਓ we write this force in terms of position vector. Then how we write in terms of position vector? This is axis x, o, y, z. Now we have a point A, r1 vector, B, r2 vector, position vector. And here we have a charge q1, q2. Again we have a force 2 1 vector, 1 2 vector, and here 1 2 cap, and here 2 1 cap. Again and again the r distance. Now we have this position vector r1, OB is a r2 vector. This is the position vector. Now force 1 2 vector, that is 1 by 4 pi epsilon naught q1 q2 r square 2 1 cap. Okay, we can write this force also 1 by 4 pi epsilon naught if we multiply and divide with r. Now what is this? Now we are considering this force, so we have to move from here by using triangle law. BA vector, OA vector, then BA vector is OA vector minus OB vector, R1 minus R2 vector. BA vector is R1 vector minus R2 vector. Now what is the difference of this AB vector te BA vector ch ki difference है? सिर्फ direction का difference है. Means AB vector किया, AB vector magnitude unit vector direction, और BA vector किया magnitude and unit vector direction. Means this thing represent BA vector, and if we have the magnitude of this, जेदा magnitude ले लिए तो R1 minus R2 होएगा. Means और जे मैं इत्थे magnitude लाऊं तो इहदा magnitude की show होएगा BA magnitude is R. Means how I write this force? F12 4 pi epsilon naught. This is magnitude. This is the magnitude. R1 R2 cube into, this is the vector form, and how we write the vector? R1 R2. So this is how the force is written in a vector form. And if it is 2 1 force, then 1 over 4 pi epsilon naught q1 q2 r2 r1 cube into r2 r1. So remember this. When you write 1 2, In unit vector form here 2, 1. But in position vector when you write 1, 2, 1 minus 2, 2, 1, 2 minus 1. Means test charge must be written. Test charge means ਜਿਹਦੇ ਉੱਤੇ force ਲੱਗ ਰਹੀ ਹੈ. Means how we define this? Charge 1 exerted force on 2. 1 on 2. So here the test charge is 2. And here 2 exerted force on 1. So here the test charge is 1. Now this is applicable to the two charges. But when we considering the system, discrete nature of charges, we have the number of charges. Then how we apply this Coulomb's law? Because Coulomb's law, here limitations ne. It is applicable to the static charges only, and it is applicable to the two charges only. Then for the system where we have the number of charges, how we apply this Coulomb's law? By using the superposition principle. By means if we have the number of charges, we just only considering the two charges, neglecting the other, and we again apply the Coulomb's law. Means the number of charges Q1, Q2, Q3 and so many charges, and we have to calculate the net force on Q1. So this is 2, 1, 3, 1, 4, 1 and so on. And how we write? 4 pi epsilon naught Q1 Q2. Now the difference is, the distance with the different charges is different. So how we write this? 1 2 1 2 square, 2 1 cap, Q1 Q3 1 3 square, 3 1 cap and so on. And if we want to write it in position vector, 2, this is 1 2 means R1 R2 cube R1 R2 plus Q1 Q3 R1 R3 cube and R1 R3 and so on. So this is how the superposition principle is applied. Now in practical form, we ignore the quantization nature, we ignore the discrete system, and we have a continuous charge distribution. And for continuous distribution we have one dimensional, that is linear, and for that we define lambda, linear charge density, charge upon length. Then surface sigma, charge upon area. Then volume, three-dimensional rho, charge upon volume. So we have the three charge distribution, continuous charge distribution. We have a three: linear, length, surface charge distribution, two-dimensional, volume charge distribution, three-dimensional. Then how we write the force by this distribution? How we write the force? By using this distribution. First we considering the linear charge distribution, and for that X, O, Y, Z. This is a test charge with position vector R dash. It's a point P. We have this length line charge distribution. How we calculate? For that we consider small element dl, or dl the upper charge dq. Then what is the lambda here? Charge upon length. So charges lambda dl. Let its position vector is r dash and it exerts the force. This position small element exerts the force. Then first we write small force. Against formula 4 pi epsilon naught dq q naught. पहले की दा position vector test charge दा cube r dash and f vector q naught upon 4 pi epsilon naught integral, and in dq this lambda dl r dash cube into r dash. So this is line integral. And for surface integral, what we do for surface integral, we have the two-dimensional structure, And we have dq, this dq sigma dA surface area, or we can say ds surface area ds. And what about here? Here we write sigma ds surface area. And for the third we have again dq volume. dq is rho dV, and we write here rho dV, and here the volume distribution. So charge distribution is of four types. Charge distribution: point charge distribution, linear, surface, volume. But the continuous distribution is of three types, that is linear, surface and volume. So this is all about the Coulomb's law, its vector form in position vector and by this distribution. And then the next we have the electric field. That is also the property of the charge. For this electric field, we have considering the two charges as electric. For this electric field, we considering the charges. First is source charge and test charge. Source charge whose field is considered, and test charge which is placed in that field to calculate the value. So the space around the point charge up to this charge affect the other is called the electric field. And how we define mathematically this electric field is force upon test charge, and we also write limit approaches to zero. It means the test charge is small, क्योंकि जब test charge भी बड़ा होएगा तो ओदा field source charge दे field नु की करेगा, affect करेगा. So this is electric field. How we write it mathematically? Force upon test charge. Newton per coulomb is its unit, and it is the alternate of Coulomb's law, where we don't apply the Coulomb's law and we have a charge and its field. Then how we calculate the force due to electric field? We can say this test charge Q naught electric field. And how we calculate the electric field due to a point charge? This is the definition for electric field, that is force upon test charge. Then how we calculate this? This is X, O, Y, Z. Now we have this source charge. This is its field. And in this field we have point P, that is at the position R vector or R cap, that is the direction of this unit, this distance. And here we place test charge Q naught. So it exerts the force. How we write the force? We have 1 by 4 pi epsilon naught Q naught R square R cap. This is the force. And what is the electric field? Force upon test charge. Then what we got? 1 over 4 pi epsilon naught Q upon R square R cap. Or we can write this R cap as 1 over 4 pi epsilon naught Q upon R cube R vector for getting the rectangular components. It means for this value, when we write it in magnitude, 1 over 4 pi epsilon naught Q upon R square is proportional to 1 upon R square. For the given charges, these are a constant. This will give that the symmetry is a spherical. The symmetry is a spherical. If we draw the graph, it will be curved graph R square, and if we 1 upon R square, this will be a straight line. And they are very important. How we define the electric field for a point charge, that is 1 by 4 pi epsilon naught Q upon R square. This is the simple form. And if we have to write this in the form of position vector, this charge is here with position vector R dash. Now again test charge with position vector R. Then we again write this value F force. Now again we have the steps, same step. That description is given in the notes, that how we get the values. But if we write the same value, 4 pi epsilon naught. First is test charge, that is R, this is R and this is R dash, cube R dash. And what we write electric field? Force upon test charge, 4 pi epsilon naught Q R dash cube into R dash vector. This is the electric field in terms of position vector of test charge, source charge and the test charge. So force upon test charge. And how we find this? Again the same step as we find the force, the values by this, if we write the name AP vectors. Okay, and representation, positive charge field outward, negative charge inward. Always remember, and the symmetry is spherical. And if again the number of charges are present, then how we get the total electric field? How we get the total electric field? That is again E1 vector, E2 vector, E3 vector and so on. That is the superposition principle. And again we write the same, we can say the summation of this, or ith form, getting the summation of this. And for surface integral, for surface linear charge distribution, whatever we have the force, 4 pi epsilon naught Q naught L lambda dl R dash cube R dash vector. Now how we write the electric field? Force upon test charge. This is the electric field. Force upon test charge. And force upon test charge means we don't have any Q naught. And these are become for linear surface volume charge distribution. मतलब remember the thing कि पहला किदा position vector लिखना सी. First we write the position vector for the test charge. Okay, and we have one term here, electric lines of force. जिन्होंने field lines भी कहते हैं. Very important. These are imaginary lines, but they are used to represent the important property of charge, that is called electric field. These are the usually lines used to represent the field, and we have the different field lines. How we draw them? Like this is the uniform field, parallel lines, okay, non-uniform field, curve lines, spherical positive charge field lines, negative charge field lines, dipoles field lines, and they are continuous curve. They always start from positive bahar nu and towards negative, and don't form the continuous loop. They don't cross each other, because at curve line they produce the tangent, give the direction, and if they cross at the intersection point, there must be a two directions, which is not possible. They never passed through the conductor. That will be explained in capacitor chapter. And they exert the lateral pressure, that is the repulsion, shows between the same charges, and they contract longitudinally, attraction, and they don't cross each other, that and give the direction. So these are the electric field lines, and these are the some important terms about the electric field, and the next portion is discussed for the next lecture. Okay, thank you.